Guys, welcome to the channel. This is Waga. We're going to do another LeetCode question, and the question in question is number 24, swap nodes in pairs. So you're given a linked list, and you're supposed to swap every two adjusted nodes and return the head, right? So in this case, we have 1 and 2, 3 and 4. You're supposed to connect 4 to 3 and 2 to 1, with 2 being the first one, and then 4 being the third one, and then connect the 1 to the 4, right? So basically what this means is we're going to need pointers and we're going to need dummy nodes, right? And we're going to move them along. You could draw it out so that you can see it. Before I did this, I had to draw it out first, see it better, and then solve it, right? But it's pretty straightforward. It's just using pointers, and make sure you keep track of where you are. So it's best done, in my opinion, if you have a piece of paper. But since we don't have that here, or you could use a REPL and walk through it, right? So let's just try and keep track of our nodes. And the thing we could do is we could start off with a dummy node, and we could just come here and say dummy is going to be list node, and we are going to, it's going to connect to our head. So you could just start off at 0. The node is going to have 0, and it's going to connect to our head, right? Like so, right? Then we have a previous and current pointers, and the previous is going to point to the dummy, and the current is going to be the head, right? So we have a node here, like if we could visualize it better, right? So we're going to have a dummy node, like we could say D, like so, and D is going to point to our current head, which is going to be 1 2 3 4. So 1, and then 2, and then 3, and then 4, like so. Wait, like so, 4, right? So we have 2 pointers, and the previous is going to be here, right? So let's just put it on the next line. The previous is going to be here, and the current is going to be at our head, right? So it's going to be like that, if you can visualize it like so, right? The next thing we do is we loop through while we at least have 2 nodes, right? Because we need 2 nodes to swap out. So we loop through while we still have at least 2 nodes, right? So we could say while current and current.next, right? Current.next. Remember, we need 2 nodes to reverse, right? While this is true, we save a few pointers, right? Yeah, so we save a few pointers. First, to point to the next pair that we need to connect to, right? So the next pair that we need to connect to is going to be the current dot next, right? So remember, our current is here, so let's just point. So the next pair is going to be on our current. Let's put 2 here, and then it's going to be on the current.next. So here we have the NP, right? So we have the next, and here this is going to be 4, like so, right? 4 is going to be there. So our pointers, there's a pointer at the dummy, there's another pointer at 1, then the next pair is going to be at 3. That is going to be the next numbers we're going to consider, right? So it's going to be on the next, and afterwards we're going to have another pointer called second, and second is just going to be on our current.next, right? Car.next, right? So our second is going to be here, right? On our current.next, right? So our second is going to be here, right? And we could just get rid of, or we could keep track of our numbers. Yeah, you could keep track of our numbers, but you could get rid of it, right? So for now it looks like this, right? So during the first pass through, right? So the next thing we need to do is we need to reverse the first pair, right? So we reverse 2 and 1, and for that we just make the second dot next, and it's going to point to our current, right? So what we're doing here is we are making the second dot next, right? This pointer is going to be point to our current, right? So what we're going to have, if we could update it, is well, let's just do it here. We're going to have P is going to point to our current, and our current is going to we're essentially doing this, right? Our second dot next is going to point to our current, right? So 2 is going to point to 1 in this case, right? And yeah, basically that's what we're doing. And then and remember okay, right? And after we do that, the next thing we need to do is the first node is now in the second position, right? And so we can make it point to the second pair, right? So what we can do now is connect it to the second pair. So for that, we just say car dot next is going to be pointing to the next pair, like so, right? So what that looks like is the current is going to point all the way to the next pair, right? So okay, showing it without drawing it is a bit hard, but basically what we have done, if we'd have more leeway if we could draw it, right? What we have done is that we can make the first node is now in the second position, so we can we point it to the second pair, right? And then the current node, which is this one, we point it to 3, right? So we point 1 to the next pair, which is going to be 3 and 4. So basically that's what you've done, right? And the next thing we need to do is we point our dummy head to the second node, which is now in the first position, right? So our dummy head, which is off camera here, or off our dummy head, now points to is now going to point to 2, right? Our dummy head is going to point to 2, and for that we just need to say previous dot next, and previous dot next is going to point to second, like so. Second, spell it correctly. So now we have moved so as it stands, what it looks like is we have our dummy which points to 2, and then 2 points to 1, and 1 points to, okay, just the arrow thingy, and 1 points to 3, and then afterwards we have 4. So this is our current state, right? And our various pointers are all over the place, right? So basically that, right? And the next thing we need to do is we need to update our pointers so that they can actually point to the next pair of nodes, right? So now we need to move our pointers from the current positions to the next pair of nodes, where we can now do the switcheroo again, right? So what we need to do is we need to move our previous we need to move our previous to our current, right? So we say previous is going to be equal to our current, right? So our previous moves to our current, and remember our current is now at 1, right? Our current is at 1, right? So our previous moves to our current moves up, and then the current moves also up to the next pair, right? So, and the current moves to the next pair, right? And so now we have successfully moved our pointers, right? So so we have essentially moved all our pointers. Now the current is going to be, the previous is going to be at 1, right? So we have the previous here, and the current, okay, and the current is going to be at the, since 1 connects to, okay, this can be a bit confusing. The previous is going to be at 1. We could just put it here. The previous is going to be at 1, and our current is going to be at the next pair. So our current is going to be here, right? And then the code is going to be called again, right? So when we come to the next iteration, first we're going to check if the next pair is satisfied. So there'll be no next pair. But the second is going to be the current dot next. So the second, this is going to be S, right? So we move S like so, and then the switch continues as expected. And when all this is done, the next thing we're going to do is just return. Our dummy was still on the list node that we connected, right? So we just need to return dummy dot next, like so, right? So if we run our code, basically, I think that's all that is required. If we run our code, It's accepted, and if we submit it, hopefully we have not made any mistakes. It's accepted. So basically that. We need to go through every single node. So that's O of n, right? That's O of n for the time complexity. The space complexity, we do not create any new structures. We just add a list node, right? So depending on how you define that, is a list node, it has a value and it has a next. It's just structure or a pointer. So basically, it can be O of n, or depending on how you construct a list node, right? So basically that's O of n for the time complexity and potentially O of n for the space complexity. Thank you for watching. Subscribe to the channel, and I'll see you in the next video.